Hi there, welcome to the second part on binary search trees. On the last part, we introduced BSTs and start seeing some of its operations. So now we are going to continue with the next operation, which will be finding the successor of a given number. So for example, you want to find which is the successor of 8. Also mind that the name does not need to be inside the tree, but we want to find which is the bigger number, the next bigger number that it's on the tree. So as always, we start at the root and we compare. Since the value we are searching for is smaller than the root, that means we can stop looking at that part of the tree and we can center on the left part. So we will move here. Now 5 is smaller than our number we're looking for, so that means that we need to continue looking. In this case, we can now disregard that part and go back to this part. Now this number it's bigger than 8, so this means two things: that this could potentially be the number we are looking for, the successor of 8, or we might still need to go down the tree. But in any case, this subtree is also done. So now we go back down from left, and since we found that the next number is smaller than 8, that means that this is not the number we're looking for, so we completely cut this down, and therefore the number we were looking for was 10. Similar operations is to find the predecessor, which is in this case the number that goes before that one. So again, if we take 8 as an example, the procedure will be pretty similar. We start at the root. Since the value is bigger than what we're looking for, this means that we can disregard the right part and center on the left one. We go back and see that the value is already smaller than 8. So that means that we can either have to continue looking or this might be the value. But in any case, we can already disregard that part since they are even smaller numbers. We continue down on the right part, and since the new value is bigger than one we're looking for, that means that 5 was not the number we were looking for, and we need to still keep searching. But also, we don't need to search in this part. We go back down, and since the number is smaller than what we're looking for, that means we can disregard 10 and we should either keep searching or that will be the number. In this case, since we are already at a leaf, that means that 7 is the number we are looking for. And the final operation we are going to see are how to delete some nodes from our tree. For deleting a node, we need to distinguish 4 cases. If the element does not exist, then we cannot delete it. And also the element could either be a leaf, or if it's not a leaf, it can either have only one child or 2 children. The first case, since if we cannot do anything, then there's nothing more after the search. And the second case, if the element we are looking for is a leaf, let's say we are looking for the value 7, then we just need to compute the search and Once we find it, since it's a leaf, deleting a leaf is as easily as deleting the subtree, since it does not affect the properties of the whole tree. The second case would be deleting an element that only has one child. Let's say that we want to delete the node 16. This case also would be fairly easy, since having only one child means that for deleting this node, the only thing that we need to do is connect its parent with its only child. Therefore, we delete the node and make the new connection, and we still maintain the BST properties. Now, finally, if the node has two children, then we need to make some changes. Let's say that we want to delete node 5. Node 5 has two subtrees because it has two children, so we cannot make a single connection like in the previous case. We need to alter the order of the subtrees. How do we do this? Well, what we need to do is to center on the right subtree and found the smaller leaf. That means the left leaf of the right subtree. That's it. We need to search for this leaf. And what do we do? What we do is replace the values of both nodes. That means now here, instead of being node 5, we will have node 7. Here node 5. And now we have replaced the problem from deleting one leaf. And as we remember, deleting a leaf has no consequences. That's all for now. Thank you.